In this video, we'll be going over linked list cycle 2. So given a linked list, return the node where the cycle begins. If there's no cycle, return node. There's a cycle and a linked list if there's some node in the list that can be reached again by continuously following the next pointer. Internally, position is used to denote the index of a node that the tail's next pointer is connected to. Note that position is not passed as a parameter. Notice that you should not modify the input linked list. So in our first example, we're given this list, and we can see that there's a cycle here at 2, 0, -4, and then we want to return the node that's the start of the cycle, which is 2, which is at index 1, because we have index 0, 1, 2, 3. So we return this node here. Let's go over the thought process. So let's break this question down. The first part is detecting the cycle. We can use Floyd's cycle detection algorithm. We can have two pointers, which is the slow and the fast pointer. Slow and fast pointer. The slow pointer moves forward one step at a time. And then the fast pointer moves forward 2 steps at a time. If the slow pointer ever catches up to the fast pointer, this means there's a cycle. Now the next part is finding the start of the cycle. So the second part is finding the start of the cycle. So let's indicate the distance between the start of the list and the start of the cycle is equal to k, which means k nodes. For example, the distance between the start of the list to the start of the cycle, we can say there's k nodes in between. And then let's indicate the length of the cycle, or the number of nodes inside the cycle, is equal to n. This means there's n nodes inside the cycle here. So when the slow pointer reaches the start of the cycle, this means the slow pointer has already taken k steps. Since our fast pointer moves twice as fast as our slow pointer, this means the fast pointer is k steps into the cycle. Now, since the fast pointer catches up to the slow pointer by 1 step at a time, so since the fast pointer catches up to the slow pointer 1 step in each of the iteration, the distance between the slow and the fast pointer is n minus k. This means when its fast pointer catches up to the slow pointer, they will be both n minus k steps into the cycle. Now, if they're n minus k into the cycle, in order to reach back to the start of the cycle again, they have to take k steps. Both of the pointers will need to take k steps in order to reach the start of the cycle. Now, how can we take k steps? We should know that the start of the list, the distance between the start of the list and the start of the cycle is k steps. We can move the slow pointer back to the start of the list. Then move both pointers forward 1 step at a time. Move both pointers forward 1 step at a time to reach the start of the cycle. Now, in this loop, the fast pointer will start moving one step at a time too. And then when they meet again, they will be meeting at the start of the cycle. Let's go over the pseudocode. So we're gonna create two variables. Our slow is the slow pointer, moves one step at a time. And then our fast is our fast pointer, it moves two steps at a time. So while fast and fast.next is not equal to null, because we're moving our fast pointer two steps at a time, we do not want to hit a no pointer exception. So I want to set slow to slow.next. And then I want to set fast to fast.next.next. Now, if slow is equal to fast, we can see that they are both n minus k steps into the cycle. This means when the fast pointer catches the slow pointer, they will be both n minus k steps into the cycle. So we can break out from this loop for now. So we can break out of the loop. But before we start moving them both one step at a time, we want to check if there's a cycle or not. So if fast or fast.next is equal to null, this means there's no cycle, so we can just return null. Now we want to move the slow pointer back to the start of the list and move both pointers one step at a time. So I want to set slow to the head of the list again. And then we can say while slow is not equal to fast, set slow to slow.next, move it one step, and then set fast to fast.next, move it one step at a time too. And then we can return the start of the cycle, which is slow and fast, so we can just return slow. Now let's go over the time and space complexity. For the time complexity, so initially, worst case scenario is going to be O of n. And then the second, and then we have another loop which is O of k, but doesn't really matter. We can just say it's O of n too. Actually, we can call it O of k, but it's still going to be O of n, where n is the length of the input list, and k is the number of steps to the start of the cycle. So O of n is initial loop, and then O of k is finding the start of the cycle. Now the space complexity is O of 1 because we did not create any extra data structure. Let's go over the code. So we're going to create our two variables, our slow and fast pointer. While fast is not equal to null, and fast.next is not equal to null, we want to move them both. We want to move our fast pointer two steps at a time, and our slow pointer one step at a time. So if slow is equal to fast, we can break out from a loop because we're currently n minus k steps into the cycle. Now if fast is equal to null or fast.next is equal to null, this means there's no cycle, so we can just return null. Now we want to move our slow pointer back to the start of the list again, and then move both pointers one step at a time. So while slow is not equal to fast, we want to move slow forward, and then want to move fast forward one step too. Then we can return any of the pointers, so we can just return slow. Let me know if any questions in the comment section below.